Hi, welcome to this lesson on trigonometry, trig identities part 1. Let's have a look at question 1. Using reduction formulae and special angles, simplify the following expression. Okay, so I'm going to get my cast diagram up and ready. And let's isolate each individual trigonometric term and try and simplify it as far as we can. Okay, so sine of 180 plus x. So if x is here in the first quadrant, if I travel 180 degrees, I end up in the third quadrant here where tan is negative. So it's going to be negative, and more so because of the 180, you're reducing off the horizontal, the trig ratio stays the same. So negative sine x. Then tan of 720 plus x. So from this x here, if I go another 360, I end up where I started, and another 360, I end up where I started. So I've gone 720 degrees from that x value. So I still end up with tan of x because tan is positive in the first quadrant. And then cos of negative x, because cos is an even trig identity, that means cos of negative x is cos of positive x. All divided by, now you're going cos of 90 plus x. So now you are reducing off the vertical line. So if I have x being here in my first quadrant, then moving it over 90 degrees, I have it in the second quadrant, okay, where cos is both negative and it changes its ratio because you're reducing off the 90 degree, the vertical, co-ratios means that it becomes sine of x and negative because cos is negative in the second quadrant. So negative sine x divided by negative sine x will divide each other out, and you're left with tan x times cos x. Now by the quotient identity, tan x is sine x over cos x, times cos x, which is just cos x over 1. So those cos x will divide into each other, and you're left with sine x divided by 1, which is just sine x. Okay, so this whole thing nicely reduces just to sine of x for its relevant defined degrees. Lastly, they asked us to find the value of sine of 570 without the use of a calculator. So what I'm going to do is I'm going to break up 570 degrees into special angles that I can work with. So it'll be sine of 360 degrees plus, what do I need to add on? I need to add on another 210 degrees. Okay, because remember sine of 360 degrees plus x is equal to sine x by your reduction formulae. Okay, you're reducing off the horizontal and you're going 360 degrees. So you end up where you started off. So this is sine of 210 degrees. But what is sine of 210 degrees? So 210 degrees is here in the third quadrant. 210 degrees. But that is 30 degrees off the horizontal. So I can write it as sine of 180 degrees plus 30 degrees. Okay, but now, since sine is negative in the third quadrant, it becomes negative, and because you're bouncing off the horizontal, it remains sine. So negative sine 30 degrees. But sine 30 degrees is a special angle. It's a half. So the final answer should be negative a half. Okay, so we did that without a calculator, but we can double check if that's correct. So if you put sine of 570 degrees into your calculator, you get negative a half. All right, so that's using reduction formulae and special angles to solve this type of problem. Awesome. I'll see you in the next one.